get the port number, we can see here we are preparing this another data structure and we are doing this bind operation. So with that the socket thing is ready. Hence I want to wrap everything inside this wrapper API rather than you just put this dirty looking code inside the main itself. So this is yet another thing. As you gain more experience, if you are a beginner especially, you should do things like this, not just put one long lengthy spaghetti looking kind of a code. Okay, so just abstract with an API so that we should understand this API does everything what we need. So come back to this libpcap example. See, in this we are doing all this to register that port and stuff like that for the libpcap stuff, as I explained in this libpcap series. So we are trying to port this libpcap sniffer to raw socket sniffer. So what we do is maybe we can do a save as, and instead of libpcap I can say raw socket sniffer. So this is a raw socket sniffer and we can remove all this unwanted code. So what we do is here above dev, yeah, so what we do is we can take the same example and instead of arg1 maybe we can just hard code for time being. So we can just remove this entire stuff which anyway we don't need. Okay, and we can repurpose this callback, which is this. Okay, something we can do, and we can change the context and repurpose that callback. Okay, so we have this arg1. Instead of arg1, let me hard code for simplicity. Let's say we say it is loopback, and let me not do it in wireless port. So create socket. So let's just copy paste this create socket part, and which is here. And this has this kind of dependency. Let me copy paste this true false and stuff, and so that addresses the dependency of return values and stuff. And then you have all this header files. So let me just blindly copy this and not to attempt doing any merge operation. So some header files may be duplicated, which is still fine. Okay, so let me copy this header files. You can say stdio, it may get duplicated, it is still fine. Okay, it should work. Okay, so we come here and then this is the callback. Okay, so we revisit this callback later. If you come to this example, here we are sending the packet, there we are receiving the packet. So after the socket file descriptor registration, it's going to be something like this. Okay, so instead of write, we do a read operation and socket file descriptor, and we need to pass a packet buffer. Okay, so what we do is, in this example we have this packet buffer something like this. So in this case we do a global variable, say unsigned char packet buff. Okay, and we put something like 2000 bytes, something like that, and we can store also its length, int. In fact, this can be unsigned int packet buff length something equal to 0, something like this. Okay, or else we can initialize in the main also if you wish to. Okay, and sometimes you can also do this packet by memset to zeros and stuff. Okay, so something like that you can do. Since this is a global variable, we can do as it is, or else we can just port it. I mean, we can just mention as arguments as well. Let's just imagine, let's just keep it as it is, and this callback we can convert it into some sort of process or something. Okay, parse packet API, and we do some changes later. Okay, so come down here, what we can do is read of this thing. So here it is going to be this packet buff, it's going to be packet buff, and here it is going to be 2000. So please note, you are not supposed to, if you are a beginner, you are not supposed to type something a random like this, number like this. You are supposed to actually do a hash define and mention that hash defined value, because magic numbers are generally a bad coding practice. So maybe we can also do some sort of hash define, packet buff max packet buff is 2000, and copy that hash define over here. Okay, so this is a generally good coding practice, and what we do is we can convert this into an infinite loop so that it keeps getting those packets. So while of 1, we do this, and it will do a read operation. Okay, it will do a read operation, and what we do is we can capture its length, how much we received. See, you can see here the fundamental difference between write and read is, in the case of write API, we are telling how many bytes has to be sent. So this is bytes to be sent. In the case of read API, we are telling how many bytes can be read, but the bytes read is always a variable. Hence, we are capturing this written variable, versus here we are not capturing any written variable. Instead, we are passing as an argument here. So that's what it is. So we get this, and all we do is if packet buff length is greater than 0, we can do also one thing, because it's an infinite loop, we can also mention this equal to 0. So we set it to 0, and then let this API run, and then we do a graceful check whether it is greater than 0, which means we received the packet, and then we can initiate this callback or this API, okay, which is this. In this case, it is this parse packet API. Okay, so since it is a global variable, I am not passing any function arguments. Otherwise, you can pass those function arguments. You can pass some packet buff is this, length is this, and then inside you can process. It is also a good coding practice. Okay, in fact, let us do something like that. Packet buff comma packet buff length. Okay, it's a good coding practice. You can see here, and here it's a pointer, unsigned char packet buff. So we change this to just unsigned star buff, unsigned char star buff, and this is unsigned int, and we call this shortly as buff length. So this should kind of make this parse packet API ready. With this API is getting this arguments. This is I'm doing since it kind of replicates you a production level code, not some weird examples, YouTube example code. So this practice also helps, especially if you are a beginner. Just learn these things. It's not writing logic alone. Some of these things is what makes the code looks like a production code. Okay, so instead of buff, instead of packet earlier, we are calling now as buff, and instead of this length, it is actually nothing but buff length. Okay, so port it wherever it is there, just port it for now, and it should be come somewhat start getting compatible, and wherever this packet is there. So let's just do search replace packet and to buff of this square bracket. So replace all. Okay, close. Hope you can see we are just doing parse of this initial 6 bytes and the rest of the 6 bytes, so that we get this destination MAC, source MAC, and type and things like that, just like the previous libpcap episodes. And for the source IP, this is our offset, and the protocol TCP UDP, this is our offset. So this is one method. The other method which the author have done is actually in this way. So again, here instead of packet, we call this as buff, and rest should be more or less the same, right? So again, here packet, we call this as buff. So rest should be more or less the same, and we should technically get the same output. Okay, so hopefully the code is ported, and let's just compile gcc -o raw socket sniffer sniffer.c. So file descriptor is undeclared, which is 119, which is somewhere here. Yeah, this is not declared, so let's just do this. and in this case I prefer to do like a global variable, and we can do somewhere here. Okay, so we can do like a global variable, and it should be ready for use over inside the main. Okay, so we compile return value, this is 122. Yeah, since main is int, so we give a return value as 0, something like that. So you can see it is compiled, and we as you must have seen, we are doing it for the port loopback. Okay, so what we'll do is I'll run it like a sudo, because you need root permission to do things in raw socket. Okay, so raw socket sniffer. Yeah, so hopefully you can see it is doing this. Let me give a extra delimiter after each packet. Okay, so we can do this print \n something like that. So we know that each time a packet ends, we get this delimiter. Okay, so printf yeah, so you can see, and we can do is ping localhost, and we can see those ping packets over here. So let me cancel this, you can see the source MAC, destination MAC are zeros, obviously, because we are doing it for loopback interface, and the type is IPv4. You can see there 0x 08 and 0x 00, which is the hexadecimal of 8 and zeros are IPv4 type, and then you have the source IP, destination IP 127, since I am pinging localhost to localhost, and then you can see there same thing with the author's logic, which is doing with this data structure way, and you can see there, even there it prints the same, and you can see IP header length and the overall other things actually, and also the protocol is 1, which means it is ICMP, which is these are ping packets, and you can see it is protocol number is 17, which is some UDP packet in that loopback interface. So same thing you can also do for other interfaces also. Let me do for Wi-Fi port, which is this, and we replace with the loopback with this port, and we quickly compile and execute. So you can see behind the scenes it is sending and receiving some packets, and that's what we can able to get it over here. So it will work like any packet sniffer, but as I said in the previous episode, the libpcap episode, our primary objective is, if you are a budding network software developer, sometimes you may work in kernel space and write any network stack in kernel space, as I did in my career as well, many instances, and sometimes you may do it in user space. Again, I have done that in my career many instances, and sometimes this stack may not be a regular TCP or UDP application. It can be some stack, or it can be an entire TCP stack you have done, which is working in the user space in some microkernel or something like that. Okay, some operating system. It may not be even Linux, some other operating system, and it may not have this, but it will have its own method to get packets to the user space, so that you can pass it through to your network stack, and then further process those packets like any other thing. So you may have your own custom application layer. You can further process it from your network stack, network layer and transport layer, assuming it is also some type of TCP IP stack, or otherwise it can be some unique specialized network stack. So in any case, if you are writing any stack in the user space, you can have multiple ways. One is this raw sockets, the other is libpcap, the other one which also you can use is this tuntap interface. I have used, as I said again, this I told again in the previous episode, you can also use tuntap. It gives again its own advantages. You can write some VPN applications and stuff in, or VPN stack in user space and stuff with tuntap architecture. So there are various cases. Knowing such things will help you and this example you can further change, modify, do a lot of things, and then you can get your things done. And hope this video is going to give you some insight. As usual, I'm going to attach this code in the video description, so you can download and then you can further modify, customize. If you have any queries, be in touch via mail or YouTube comments if it is a very small query, or if you are interested, you can also consider joining classes which I do conduct to most students who are already in the industry, working in some project or other project, and they want to improve their skills, they want to proceed further as a part of their career. So hope you loved this video. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.